everybody. Today we're going to cover more graphs of rational functions. So I've called this Graphs of Rational Functions Part 2. So we're going to start with the approach of graphing rational functions using transformations. So hopefully you remember when we have f of x and we add or subtract some constant c, that will be a vertical transformation. So we'll see the graph shift up or we'll see it shift down. If we have f of x plus or minus c, where that plus or minus is inside of the function, then that's going to be a horizontal transformation. Super important to remember that when we're moving a rational function, we will also move the asymptotes. We'll only do this transformation for the function f of x equals 1 over x. So let's start by looking at what that graph would look like. 1 over x is going to have a vertical asymptote when x is equal to 0. So that goes along the y-axis. And because the denominator is power 1 and the numerator is power 0, we have a horizontal asymptote along the x-axis. So our HA is y equals 0, our VA is x equals 0. Then 2 points to really help you draw it would be if I put in 1, I get 1. If I put in -1, I get -1. The graph comes down along the vertical asymptote and curves along the horizontal, and then the same thing on the left side. It comes along the horizontal and goes down the vertical. So you have this split graph. What I want to do with that then is do 1 over x minus 4. So just a transformation. So I want you to think this minus 4 is going to go to the right 4. So this graph that we just had, 1 over x, should move to the right. Since we are only moving to the right, we are only going to change the vertical asymptote. It will now be at x equals 4. So here I can draw my vertical asymptote. The horizontal asymptote is going to stay at y equals 0. And what I kind of like to think is this point was 1 over 1 up. This point was 1 over 1 down, kind of from this little place where it crossed. It happens to be at the origin because this is just our basic 1 over x. But we have this new point here where these two lines cross because of my transformation. So if I go 1 over and 1 up, I have a point. Then if I go 1 to the left and 1 down, I will also have a point. These 2 points will help me draw the graph, so I'll draw toward the asymptotes on each side. And that's all I need to do. So let's look at that a different way. I have 1 over x plus 3. So this time the plus 3 outside says this is going to be a vertical transformation up 3. So since I'm going up 3, I know that I'm moving my horizontal asymptote. So my horizontal asymptote goes up to y equals 3. That says my vertical asymptote didn't move. It'll still be at x equals 0. Then I can locate those 2 points, 1 over and 1 up. There's my first point, then 1 over and 1 down. There's my second point. We can then connect the dots, kind of make it follow the asymptotes. I know I don't have great graphing skills, but it gives you the idea of what it should look like. So let's try both of those at once, both a horizontal and a vertical shift here. The x plus 2 says we're going to move to the left 2. So we have a vertical asymptote at x equals -2. And then the minus 4 says we're shifting down 4, so I have a horizontal asymptote at y equals -4. So let's put both of those in. So here's -4, and then here's -2. I like to see where they cross. That way I can go from where they cross, 1 over and 1 up. There's a point. 1 over and 1 down. There's another point. And then again, connect the dots. Not really connect the dots, but use the dots to follow the asymptotes. Let's go back and review the other little pieces we have because I have one more thing to show you in this video. So let's say I had a function 3x squared plus 10x plus 3 over 3x squared plus 10x minus 8, and I just want to know some basics. Y-intercept, x-intercept, vertical asymptote, horizontal asymptote. I like to look at it in this format, but I also like to look at the factored format. So what I'm going to do is look at 3x squared plus 10x plus 3. 3, because it's prime, can only factor into 3x times x. 3 is still prime on the other side, so I can only factor into 3 and 1. Because I want to get 10 as my middle term, I know I want to put this 3 way over on the right, this one here, they're both plus. So now you can see 3x times 3 is 9, plus 1, that gives me 10. The same kind of thing in the denominator. I have 3x squared has to break up into 3x and x. And the question is, do I break up 8 as to 8 and 1, or do I make it 4 and 2? And you really want to make it 4 and 2, where you have 3x times 4, that becomes 12, and then 2 and x becomes 2. So if I have positive 12 minus 2, that'll give me my 10x in the middle. My first scan through is really to see, do I have a hole? Is there anything I can cancel out? And I don't see anything, which is good news. It means go ahead and go to the next step. Now I'm going to kind of bounce back and forth between the factored form and the original form to answer these questions. The y-intercept comes from plugging in f of 0, which I wouldn't use the factored form. I would just go to the last two numbers. So I get 0, negative 3 over 8. All the x's would disappear, and so you can just go to the constant terms of the top and bottom to get your y-intercept. The x-intercept, though, you're going to take from the factored form. The x-intercept looks at when is the numerator equal to 0. So I have this 3x plus 1 and x plus 3. 3x plus 1 is 0. When 3x is negative 1, x is negative 1 over 3. And then the x plus 3 is 0 when x equals negative 3. So I'm going to write the intercepts as points because I don't want you to get confused between vertical asymptotes and intercepts. So I have negative 1/3, 0, and negative 3, 0. To get the vertical asymptote, I am also going to the factored form, but I'm looking at the denominator. So I look at 3x minus 2 is 0, and x plus 4 is 0. This says 3x is 2, x is 2 over 3, and then x plus 4 says x is negative 4. Now this time I want to write the asymptotes as lines, so you do keep the x equals, which is why I kind of made it a point to say, like, write the x-intercepts with coordinates and write the asymptotes as equations. The last thing I want is the horizontal asymptote. I'm going to go back to the original format and look at the first terms. So the leading terms, both are x squared, so I do 3 over 3, which is 1, so I have y equals 1 as my horizontal asymptote. So I covered that quickly again, just because we're going to go backwards now. So now I'm going to give you the graph, and we're going to come up with the equation of the function. What we're going to do is just assume that no factor has an exponent greater than 3, so we don't have to worry about multiplicities. Multiplicities will be 1 for everything. But what's going to help me is I can see vertical asymptotes, I can see intercepts, I can see horizontal asymptotes, so that should lead me to what the equation is. So first off, let's just look at this asymptote. I see one at 3 and I see one at negative 4, so that says x minus 3 and x plus 4 should be in the denominator of the function. The next thing I would look at is the horizontal asymptote. And because the horizontal asymptote is at 0, it means the degree of the denominator is greater than the degree of the numerator. So I should only have degree 1 in the numerator because I'm degree 2 in the denominator. So I look for my only intercept, which is at 2, and that says x minus 2 goes in the numerator. So let's say that's equal to f of x. I do think it's a good idea to maybe throw in 0 and make sure you end up in the right place where you expect. So think about if I did f of 0 here, I would get negative 2 over negative 3 times 4. Negative negative cancels. I would have 2 over 12, which is 1 over 6. That looks pretty good. I can see it's much smaller than 2. The reason I really want you to do that is to catch if there's a reflection. So if there's some kind of negative thrown in there, you're not going to catch it unless you do one more thing, like throw in the intercept to see where it's at. Let's try one more of those. Same directions. We're going to find the equation of the function. We're going to assume no factor has an exponent greater than 2. So I'm going to start the same way. I'm looking and I can see here's a vertical asymptote that looks like it's at x equals 1. Here's another one that looks like it's at x equals negative 5. So immediately I say, you know what? I think I have an x minus 1 and an x plus 5 in the denominator. This time, when I look through, I can see a horizontal asymptote, and I think kind of drawing on it really helps me. And it looks like it's y equals negative 1. So that means I should have the same power in the numerator as I do in the denominator. So let's look through and see if we can find some intercepts. I see one here at 3, And I see one here at -3. So I have x plus 3 and x minus 3. Now, last time I said, like, plug in 0 or something to see what's going on. So we could try that strategy again. I got two things going on in here I want to show you really. So this is 3 times -3 over -1 times 5. I have -9 over -5, which is +9 over 5. Now, when you look at it, our intercept is actually negative, not positive. So that does say we need to have a negative in front of this function. Hopefully you also saw that from the y equals -1. If I have a horizontal asymptote, that's negative. It means when I did the division, I had a negative coefficient. So we had kind of two checks there to make sure that that worked. So our final answer is this negative x plus 3 times x minus 3 over x minus 1 times x plus 5. I hope that helps. Good luck.